let's now do our first hypothesis test, and that first hypothesis test will be the very simplest. It'll involve an average. In the long run, we'll need to know that this is a one sample two-tail large. Alright, let's have a look at the problem. Alright. This problem is the one we're going to deal with first. The manager of a gas station believes that the average sales receipt is $15. Okay, that's a number that was pulled out of the air, the $15. But it's a number that we need for each and every problem. Alright, that's the thing we're going to test. We'll see it in the long run. To do the test, though, we need to check this belief against sample data. So to check this out, a random sample of 50 sales receipts is taken. Right? N is 50. The average from this sample is $13.85. That's the X bar. And the standard deviation is $6.12. That's the S. Using a 5% level of significance, that's the alpha, total area of the tails, test whether the manager's belief is accurate. Alright, so this is the very basic type of hypothesis test, and everything that we need is there, and nothing extra is there. Alright, so let's write down our sample data. Alright, so sample data. N is 50 sales receipts. The average was $13.85. This number here. That's for the sample average, and the sample standard deviation was $6.12. Alright, we're going to do this test with an alpha of 5%. So right now we're going to do the test. I'm going to include some notation that in the long run we'll leave off, just to tell you what we're doing. We have a hypothesis test, where we state our hypotheses. Alright, null hypothesis H sub O is that mu is equal to the believed value. Alright, so in other words, we'll do this interpretation better in subsequent problems. The mu here refers to the true average, and hypothesis says that the true average is equal to 15, which is the believed value, or we'll just say belief. Remember, the null hypothesis always must include an equal sign. Alright, next, the complement of the null is the alternate. So mu is not 15. So the reality must be one of these two. Not 2, not 0. Must be one of these. Alright, so again we can write something like that the true average mu is not equal to the belief. Alright, those are the hypotheses. Second step, the calculations. Alright, we start these calculations with the assumption that the null hypothesis is correct. I have to start somewhere, and that's why we want the null hypothesis to include an equal sign. If it did not include an equal sign, we can't base our calculations on that. If the null hypothesis is correct, then we have a sampling distribution of all possible sample averages, and that the mean of that distribution is equal to the mu and the null, right? If the null is correct. So mu is equal to 15. Alright, so this then would be the true distribution if the null is correct. Most of all possible sample averages will fall between two limits. Alright, what is our most going to be? Well, we're going to use the middle 95%. Why the middle 95%? Well, we are told in the problem to use a level of significance, or an alpha, of 5%. Okay, that's the total area in the tails. So that we have a symmetric distribution, 2.5% in the upper tail, and 2.5% in the lower tail. Alright, we're going to call these two limits here the critical limits. Alright, so the critical limits are calculated with this formula: mu plus and minus z value in general with half of alpha in each tail times the standard deviation, or really the estimated standard deviation of this probability distribution, S sub x bar. Alright, from the picture above, the z that we need with half of alpha in each tail is actually the z with 0.025, and as we'd seen a little while ago, the z value with 2.5% in the tail, alright, z is the bottom line of the t-table, so the z value is 1.96, right? This is the 2.5% column, this is the row for the z, and so 1.96 is our number. Alright, the other number we need, the mu is easy, the other number we need to get this calculation rolling is S sub x bar, S divided by the square root of n, S was $6.12 divided by the square root of the sample size of 50. Alright, we need to do our calculations now. Of course, bring your calculator to all classes and sessions where you're going to study. Alright, so enter 50 into the calculator, take the square root. I'm going to invert it, so we have 1 over the square root of 50. And then I'm going to multiply by 6.12. And the number on the screen of my calculator is 0.86549887, and clearly that number is too long. Right? There's too many numbers there. In general, we will, in this class, round to 4 significant places. Alright, notice it's not decimal places, we're talking about significant places. When we talk about significant places, we don't care about the preceding zeros or zeros at the end. So the number we're really looking at is the 8654987. Forget decimal place and zeros before and after. So we take 4 numbers and look at the fifth. If the fifth number is 5 or above, the fourth number gets rounded up to a 5, and if it's not, above 5 or above, we just leave it the way it is. So that number for S of x bar is to 4 significant places, 0.8655. Okay, you can either use that number in your calculator for subsequent calculations, or you can use the more accurate number. Okay. By the way, the number on the screen of your calculator might be slightly different from this. Calculators sometimes round differently.